This week's topic is acid-base interpretation. I'm going to start out by making a certain assumption, and that is that in the body there are only two substances, acid and base, and that they get combined together to give you a mixture that is a combination of the two. So I have my acid and I have my base, and when I pour the two together in this middle container, then I'll get a mixture that combines them. And if I mix them exactly evenly, then I will have an exactly neutral pH. If I have more acid than base, it'll be more acidic. If I have more base, then it'll be more basic. So that's my assumption that I'm going to make about how to do acid-base interpretation to begin with. That you just have acid and you just have base and you mix them together. So first I pour a little acid into the container. Now I add a little base, and you can see that the two are starting to blend together a little bit here. If I put a fairly even mixture of the acid and the base into the container, then it will turn out to be a pretty evenly mixed combination of the two. So if this were acid, pure acid with a pH of 1, and this were pure base with a pH of 14, then this would be a pure mixture with a pH of 7, because 7 is an exactly neutral pH. Now, if I were to pour more acid into the container than base, then I would end up with a more acidic mixture. So a mixture like this, which has more red than blue. But if I put in more of the base than I did of the acid, then I'd end up with a combination that was more base than acid, so a more blue than red combination here in the middle. So let's take this analogy that we've made with mixing an acid and a base and put it into our ABG interpretation rules. So we want to learn how to interpret an ABG, which is a combination, which we're talking about the pH. The pH is a combination of the CO2 and the bicarbonate. The CO2 acts in the body as an acid. So acid, CO2, is acting in the body that way. This is a little bit simplistic, a way to look at it, but we'll just look at it that way for now. And then bicarbonate acts in the body more as a base. So when you mix them together, then you get a neutral pH. In the body, a neutral pH is 7.40, not 7.0. Now, in order to interpret an ABG using just pH, CO2, and bicarb, just those three factors, to interpret the acid-base status, then we start out with our absolute normals, the perfectly normal, like medium values. For pH, 7.40, for CO2, 40, for bicarb, 24. And then they operate within a range, which is considered the normal range. So for pH, that's 735 to 745, CO2 is 35 to 45, and bicarb is 22 to 26. Remembering that CO2 acts as an acid in the body and bicarb acts as a base, then we move on to our interpretation methodology. We'll look at our ABG and label each component as either A for acid or B for base, based on the absolute normal value first. That is it one side of the 740 less, in which case it would be acidic, or the other side of 740, which would make it basic if it's greater. So then we would label the blood gas as either acidosis or alkalosis based on that. Then we fill in respiratory or metabolic, assuming that CO2 is respiratory and bicarb is metabolic, for whichever one of these two matches up to the acidosis-alkalosis state. Finally, we look at the range of the pH. So up here, the range of the pH. Is the pH in our blood gas in range? If it is, then it's a compensated blood gas and you're all done. If it is out of range, you have to look at the compensatory factor. That is the one that is compensating for the causal factor. If the pH, or excuse me, if the compensatory factor is in range, it's uncompensated. And if it's out of range, it's partially compensated. And that's because we're making the assumption that if the compensatory factor is in range, it's not even trying to compensate, and so the blood gas is completely uncompensated. But if the compensatory factor is out of range, it's trying to compensate, so it's partially compensated. So let's take this to try interpreting an actual blood gas. So here's a blood gas, and we're going to follow our rules and first label each component as A or B based on the absolute normal value first. So this is less than a pH of 740, so that makes it a C. So I label that with an A. Now I look at the CO2. The CO2 compared to the absolute normal is slightly less. Since CO2 acts as an acid, more of it would be acidic, less of it would be basic. So that means that this would be labeled with a B. And finally, my bicarb, which is 12. Compare that to the absolute normal of 24. Bicarb acts as a base, so when there's less of it, it's going to be more acidic. So I'm going to label that with an A. So now I can see that I have, since this is acidic, the pH is acidic, then my overall blood gas is acidosis, so I'm going to fill in acidosis here. Next, I have to fill in respiratory or metabolic, assuming it is not both. So that goes with whichever one of these two matches this. The metabolic, or bicarb, matches the pH, therefore the cause is metabolic. So down here, I'd fill in metabolic. Finally, I look at the range of pH compared to the pH I have. The range of pH that's normal is 735 to 745. Mine is 7.10. It is not in range, so it is not compensated. I have to decide now if it's partially or uncompensated. So I look at my compensatory factor. Since metabolic is the cause, then CO2 is the compensatory factor. Its normal range is 35 to 45. This is in range. Therefore, my blood gas is uncompensated. So it's an uncompensated metabolic acidosis. That is my full interpretation. I have a blood gas that is more acid than base because it's more acidic. So it is more analogous to this drawing that we made earlier than to the other ones. So that's the basic set of rules for interpreting a blood gas. What we want to do now is practice with more ABGs.